Okay, today we're going to talk about areas of trapezoids. Okay, so before we talk about the areas of trapezoid, we're going to need to define the altitude of a trapezoid. So here it is. Somebody read this for us. How about, let's see. Give me a sec. Yeah, write it down. How about, Johan, can you read this for us?
Altitude of a trapezoid is any segment perpendicular to a line containing a base from a point on the opposite base. Since the bases are parallel, all altitudes have the same length, called the height of the trapezoid.
Okay, and what does it sound like? Very similar to the heights of a triangle? Yeah, I get parallelogram, right? Okay. Rectangle, parallelogram, yeah, it's all similar, right? So it's just basically a perpendicular segment, right? What does it say? Any segment perpendicular to a line containing the base from a point on the opposite side of base. So here's a picture. Okay, so you know this height. You have to sometimes you have to extend the base, just like for the parallelogram and so forth. Right? You guys remember? You got to extend the base. This time it has this is height. As you can see, if you are to extend these two, remember by the definition of trapezoid, right? You have exactly one pair of opposite side parallel, right? So the perpendicular segment from each, right? Any of that parallel lines is going to be equal distance, right? So the height is going to be always same. And here is the theorem. The area of a trapezoid equals to half the product of the height and the sum of the bases. So in short, A is equal to half times the height times, in parentheses, B1 plus B2. Okay, so write that down. And of course, it's a theorem, so we're going to think about how we could go about proving this, okay? I'll wait for you. Write it down. And as you write it down, think about how you could prove it, okay? So, here's a picture. And I bet a lot of you looking at the picture go, okay, that's sort of easy to prove, right? What do you think the, no? Not really? And some of you. Okay, so first of all, let's write down the area. What did we say? The area is equal to half times height, B1 plus B2, right? That's what we want to prove. Isn't that right? So, any idea as to what we're going to do? Look at those dotted lines, and they sort of divided this into two what, guys? And then it's got area 1, area 2. If I know the area 1 and area 2, what can I do with these two areas to get the area of this trapezoid? Add them together, right? That's the idea. So let's figure out what is area 1. What's it look like, area 1? Triangle. Do we know how to find the area of a triangle? Yeah. So let's look at A. Can I do A1 like this? Yeah. So area 1. What's the? Let's start with the formula. Half times base times height. So let's plug it in. Half times. What's our base of this area 1? B1. What's the height? H. Okay. So that gives you what? B. Let's just leave it this way. That's fine. Okay, and then let's look at area 2. Do we know how to find the area of this second triangle?
Yes.
What is the base?
B2.
Yeah, okay, so half times B2. What's the height?
H.
H, same thing. Remember, to find the height of, this is an obtuse triangle, right? If you want to find the height, you have to extend the base, and then from this vertex, you draw a perpendicular line to that extended base, right? So, it's same with height, right? So well, let's add them together. And we want to remember, we want to get this as the area of the trapezoid. So when we add A1 plus A2, what do we get here? A1 plus A2 will give you half of B1 times H plus what? Half of B2 times H. And how can we rewrite it this way? Because I claim that we're done. All we have to do is what? One person see it? That's it? Really? Okay, everybody think about it. It's a team. Go ahead, everybody. Okay, team. So, basically, what do you have to do here, guys? Still one person see it? And now it's different one. Oh, two. Okay, how about Charlie? What did your group come up with?
Factor out the half H.
Yeah, factor out the common factor. Remember greatest common factor? You got a half here H, half here H. You guys remember how to factor? Okay, so this is half times H. And then what's left? When you do this, this is kind of like distributive property backwards, if you think about it, right? That's what you would write down as your reason if you had to, because you're going backwards. There you go. Isn't that what we had? So that's the area of a trapezoid. Basically, you have two triangles with the same height. Okay, and you add them together. Easy enough? Okay, so that's the area of the trapezoid. All right, good. Okay, everybody try then this example as a team. Find the area of a trapezoid with height 7 and base 12 and 8. Have you noticed they don't give you the pictures and so forth, guys? Guys, have you noticed that? They don't give you pictures. Guess what you got to do? Draw the picture, draw the figure, and then come up with the area. Go ahead, everybody try. I'll wait. All right, so what did your team come up with? How about Lauren, what did your team come up with? Over here. 70. How many people agree with Lauren's team? 70? This one's easy, right? All you have to do is really, like some of you said, oh, I didn't have to draw. You're right. This one, because they give you the height and the base, right? 2 bases, right? So you just plug into the formula, you get 70. Easy enough. Is that okay? Yeah. Thank you. So then let's look at next one. Find the area of an isosceles trapezoid with leg 5 and base 6 and 10. So this time it's a little bit different. They give you the legs 5 and then they give you the 2 bases. Okay, how would you do this one then? By the way, have you noticed? Anyway, go ahead, everybody try. Okay. We like isosceles triangles, isosceles trapezoids, don't we? It's kind of nice, aren't they? Those are nice. Anyway, go ahead, everybody try this one. So how many people drew this time? At this time, you kind of need to draw it, right? So how many people got this picture right here?
Yeah.
Okay. Oops. I think you... Okay, so now, what's our problem? Right now, we only know the what? 2 bases and the legs. How are we going to figure out the height? How about... What did your team come up with? How about Joseph? What did your team come up with?
Pythagorean theorem.
Yeah, we just use the Pythagorean theorem because we like isosceles trapezoid, isosceles triangle, things like that. Because, look, if I were to draw the height over here, don't you get a triangle right here? What kind of triangle is this?
Right.
Yeah, because height is perpendicular to the base. Now, how do I know that this is 2 right here? It says 2. Okay, because that's the important part. And that's why we like isosceles, trapezoid or either triangle. Jesse, how do I know this is 2 right here?
This is 2 because base is 10 and you're forming a rectangle, so the area that you cut off is 6, and then since the triangles are congruent.
Exactly. And why are these 2 triangles congruent? So very good. This top right here is 6. So if you were to draw a rectangle right here, this is 6. So therefore, what's left? 4, right? So we got to divide that by 2. And how come these 2 triangles are similar? I mean, congruent? Because how about how about Chris? Why?
Wait,
HL.
yeah, not.
Yeah, you can you do it?
You're right.
HL?
Yes.
Yeah, you could do HL. Yeah, and also it's an isosceles trapezoid, so we know, right? These 2 base angles are congruent, so that you could use that too. HL works too. So that's good. Does that make sense? Okay, so by HL we know that the 2 triangles are congruent. So we know, right? Those 2 base of the triangles must be 2. So to find the height is easy. It's square root of 21, right? Use the Pythagorean theorem. And once you know the height, you're done, right? Just plug into the formula. So how many people got? You plug it in, half times the height, which is rad 21, in parentheses 10 plus 6. How many people got 8 rad 21 as the answer? Very good. Easy enough? Okay. Can you do something like this for your homework tonight?
I hope so.
Very good. Very good. Of course, they get interesting, right?
Yeah.
All right, good.